going to focus on stars and constellations. Now, to understand what a constellation is, we need to address what stars are. Stars, just like our sun, is a ball of plasma that radiates energy from inside, and they are self-bound by gravity. A star is believed, this is a hypothesis, but it's believed to be made from a collapsing nebula. A nebula is a cloud of gas and dust, and we're going to talk about that when we talk about cosmology next week. Now, the atoms inside the nebula apparently accelerate inward due to the force of gravity. They collide, those atoms collide, and then that's going to pretty much create a protostar or young star. Now, when we classify stars, we're going to focus on color or surface temperature. So the color of the star, if it's blue or white, that's going to be the hottest, just like a flame. And then if it's going to be red, it's going to be the cooler, the older star. Our sun is a yellow star, so that's right in the middle. Now, for the size, there are red supergiants, red giants. There are blue supergiants as well, and there's also red dwarf stars. So we can be talking about size. We can also be talking about composition, which is either hydrogen, helium, and we're also going to be talking about luminosity, or the energy given off, the brightness. Now remember, Henrietta Swan focused on luminosity and variable stars. Now for a red giant, because it's red, it's going to be not as hot, and for a giant, generally it's going to be the older star. And so basically this is towards the end of the star's life. It's estimated that and believe that it will expand 9 times its size, and then basically carbon, neon, silicon, oxygen will fuse inside the star, and then it will move towards the end of its life and create a supernova. Now, a good example of a red giant is Betelgeuse, and this is found in Orion, the constellation Orion. When talking about star brightness, we're going to focus on the magnitude of the brightness. Magnitude is referring to the degree, or how much, how strong is that brightness. So when we're dealing with magnitude, we'll talk about absolute and apparent magnitude. Absolute magnitude is the real brightness of the star, how much light is really given off, while apparent is referring to what we think or what it appears to be given off. So it may seem to be brighter than what it really is. Now for star distance, we're going to focus on light years. Now a light year is the distance light travels in a year. So we have, and in this case, 6 trillion miles. Now the speed of light is 186,000 miles per second. And we've actually talked about a parallax before when we've talked about. Now we did learn that Cassini did use the parallax method to determine the distance between Mars and Earth. And the parallax is this apparent shift that a star has over a period of time, and the closer the object, the more it will shift position in the sky. So the closer it looks, okay? So the parallax angle is an angle between Earth at one time of the year, and astronomers can use this angle to find the distance from the Earth to a planet or to a star. Now, because of this angle, nearby stars will seem to be moving more relative to distant or background stars. So if you put an object up close to your face, or put an object that's closer up, and you're looking at that object move, and then you have other people maybe moving way far in the distance, it will look like the one that's closer is moving faster, but that's because it's closer. Now we're going to move into constellation. A constellation is a group of stars forming a recognizable pattern that's traditionally named after a mythological figure. Now there's a total of 88 total constellations, but we're only going to focus on 10 of the 88 constellations. We're going to focus on the history behind it, the picture or the design, the pattern that the constellation makes. So what I'm going to do is I'm actually going to show you the picture of the constellation, and then I'll just stop it, and you'll record the main star, pattern, the history or myth behind it. Now before I show you those, make sure you're aware of Johann Bayer, who assigned each star with a lowercase Greek letter. And make sure you're aware of the stars that are paired together are called binary stars, bi meaning two. Now, these are usually linked together by gravity or gravitational pull, and they may revolve around each other. Now, that's something to be aware of. We're going to talk about